75-volt constant on-time PFET buck switching controller by National Semiconductor. Welcome to the training module on the LM5085Q. This training module introduces the features and applications of the LM5085Q 75-volt constant on-time PFET buck switching controller. The LM5085 is a high-efficiency PFET switch and regulator controller that can be used to quickly and easily develop a small, efficient buck regulator for a wide range of applications. This high-voltage controller contains a PFET gate driver and a high-voltage bias regulator which operates over a wide 4.5 to 75 volt input range. The constant on-time regulation principle requires no loop compensation, simplified circuit implementation, and results in ultra-fast load transient response. The use of a PFET in a buck regulator greatly simplifies the gate drive requirements and allows for 100% duty cycle operation to extend the regulation range when operating at low input voltages. Constant on-time control is implemented using an on-time one-shot that is triggered by the feedback signal. During the off time, when the PFET or Q1 is off, the load current is supplied by the inductor and the output capacitor. The P-gate pin output swings between Vin Q1 off and VCC pin voltage Q1 on. This page shows a typical performance characteristics of the device. Efficiency versus load current and current limit versus Vn are shown. The LM5085 requires a minimum of 25 mV peak-to-peak ripple at the FB pin in phase with the switching waveform at the SW node for proper operation. The minimum ripple configuration employing C1, C2, and R3 resulted in low ripple amplitude at Vout, determined mainly by the characteristics of the output capacitor and the ripple current in L1. This configuration allows multiple ceramic capacitors to be used for Vout if the output voltage is provided to several places on the PCB board. The ripple required for the FB comparator pin can be generated with very few external components. The LM5085 can be shut down by grounding the RT pin. In this mode, the PFET is held off and the VCC regulator is disabled. The internal operating current is reduced. Releasing the pin enables normal operation. The RT pin must not be forced high during normal operation. The LM5085 current limiting operates by sensing the voltage across either the RDS(on) of Q1 or a sense resistor during the on time and comparing it to the voltage across the resistor RADJ. The current limit function is much more accurate and stable over temperature when a sense resistor is used. The RDS(on) of a MOSFET has a wide process variation and a large temperature coefficient. This slide gives information about the soft start and thermal shutdown modes of operation. The soft start feature of the LM5085 allows the regulator to gradually reach a steady state operating point at power up. The soft start circuit also activates when the device is enabled by releasing the RT pin. The LM5085 should be operated such that the junction temperature does not exceed 125 degrees C. An internal shutdown thermal circuit activates at 170 degrees C to disable the VCC regulator and the gate driver. This slide gives application information on parts selection of RFB1 and RFB2, RT, and PFET. More part selection information are given on L1 and Cout. This page shows the typical application for the LM5085 device. The operating frequency remains nearly constant with line and load variations due to the inverse relationship between the input voltage and the on-time. The PFET architecture allows for 100% duty cycle operation for a low dropout voltage. Either the RDS-on of the PFET or an external sense resistor can be used to sense current for overcurrent detection.